Okay, section 3.4 is on linear programming. All right, linear programming is a method of finding a maximum or minimum value of a function that satisfies a given set of conditions called constraints. So a constraint is one of the inequalities in a linear programming problem. So a constraint is basically some kind of inequality that limits an amount that you have. So limits amounts. So I think the first problem we have is a bakery problem. So maybe you only have a certain amount of flour or a certain amount of, I don't know what else you use there, oats, something like that. All right, the feasible region is the solution to the set of constraints graphed. So it's basically the overlapping shaded area. Like we did yesterday. Okay, so for number one, we're going to start out pretty simple with these. We're going to say just graph the feasible region for the following constraints. So this is just what we learned in 3.3. So we're going to do x is greater than or equal to 0. So if I had x equals 0, is that a horizontal or vertical line? Vertical, right? So I see Carolyn moving her hand up and down, so it's vertical line. So if I have x is greater than or equal to 0, that's this vertical line, and it'd be everything on the right of that line. So far we've chopped off half of our graph. We have everything just on the right of our graph. Okay, then I have y has to be greater than or equal to 1. So if y is greater than or equal to 1, I'm going to go ahead and number these two so we can remember which ones, just for your notes. So if I have y is greater than or equal to 1, here's y equals 1, the horizontal line at 1, and you're going to have everything above that. So now think about where the overlapping area is. We're in the top right part. Okay, the third one is 2x plus 3y is greater than or equal to 6. So since this is set up in that standard form, it's really easy to do the x-intercept, y-intercept method. So x-intercept, cover up the y. So you get 2x equals 6. So that means x is 3. So you're going to have 3, 0. For the y-intercept, cover up the x. That means 3y equals 6, so y is 2. So 0, 2. So I have 3, 0. And be careful that you're going with your original origin, right? You're not on the y equals 1 line. All right, and then 0, 2. Okay. Okay, so we have that line. Since we didn't solve for y, you always have to check the points. So we're going to check 0, 0. When we check 0, 0, we get 0 is greater than or equal to 6, which is false. So that means 0, 0 is not shaded. So I don't shade downwards, I shade up. So far we've just chopped off that little tiny corner there. So we still have the top fourth, top right fourth, and now we've chopped off this little tiny corner right there. Do you guys see? Okay, and the next one, so we'll do x-intercept, y-intercept on this too. So x-intercept is 4, y-intercept is 3. So 4, 0, 0, 3. So it's just a little bit more than it. And when I check 0, 0 on this one, I get 0 is less than or equal to 12, which is true. So that means I shade towards 0, 0. So do you guys see the final shaded area?
It's tiny.
Yeah, it's real little. Yeah. It's like a trapezoid shape. It's right there. Okay, that's what we call the feasible region. So the constraints are the inequalities. and then the feasible region was the final shaded area. Okay. So let's get a little bit harder here. Okay, so it says Brenna's Bakery bakes 2 kinds of bread, honey oat and whole grain. One batch of honey oat bread uses 5 pounds of oats and 3 pounds of flour. So that's probably going to be important, so let's underline. So honey oat uses 5 pounds of oats and 3 pounds of flour. One batch of whole grain bread uses 2 pounds of oats and 3 pounds of flour. The company has 180 pounds of oats and 135 pounds of flour available. So those are your constraints. That's what you don't have enough of, right? So something's holding it back. So write the constraints for the problem and graph the feasible region. Okay. X is the number of batches of honey oat bread. Y is the number of batches of whole grain bread. So if I make 1 batch of honey oat bread, then I'm using 5 pounds of oats and 3 pounds of flour. If I make X number of batches of honey oat, then I'm using 5x pounds of oats, 3x pounds of flour, right? Okay. Let's talk about what's holding it back. We're going to talk about the oats and the flour. So these are going to be my constraints. So I only have a certain amount of oats available. I have 180 pounds of oats. So I know I'm going to have everything is less than or equal to 180. For my flour, I only have 135 pounds of flour available. You can tell me what the rest of my inequality is for oats. Yeah, Gabby, what do you think?
5x plus 2y.
Did you guys see where she got that? 5x plus 2y is less than or equal to 180. So when we talked about oats, we had 5 pounds of oats. So that was up here. And then we used 2 pounds of oats for the whole grain. So for 1 batch, it was 5 pounds. But we didn't use 1 batch. We used X batches of honey oats, right? So X times 5. And Y batches of whole grains. So 2 times Y. You got it? Oops. Okay, for the flour, think of the same thing. So for the honey oat bread, we had X batches, and for each batch we used 3 pounds. So we have 3X. And then for the whole grain, we used 3Y. Okay, those are 2 of 4 constraints. You also have 2 very, very simple ones. Think about it. Are you going to have a negative number of batches? No, you can't make a negative number of batches of bread. So your last 2 constraints are X is greater than or equal to 0 and Y is greater than or equal to 0. Because the number of batches you have can't be negative. So you're either going to make 0 batches of honey oat or more than 0. You're not going to make a negative number. All right, so those are the 4 constraints. So those are the 4 things that you would need to graph. Okay, do I have a graph for you guys now? Okay, let's graph the feasible region. All right, these ones are good to use the intercept method with. Get my calculator. So the x-intercept, if you plug in 0 for y, you get an x-intercept of 180 divided by 5. So it's 36, 0. And a y-intercept of, if you plug in 0 for x, you get y is 90, so 0, 90. So let's go by tens. All right, so I'm going to have 0, 90, and then 36, 0. Notice I only drew the first quadrant. I wasn't really worried about the second, third, or fourth quadrants. Why did I only draw the first one? Yeah, there's no negatives, right? So this right here, when x is greater than or equal to 0 and y is greater than or equal to 0, that means you're in the first quadrant. So you don't even have to shade that if you just remember you're only in the first quadrant. Okay, the next one. So if I do 135 divided by 3, you get 45. So your x-intercept is 45 and your y-intercept is also 45. Okay, think about where we would shade the first one. So if you plug in 0, 0 to your Oates inequality, 0 plus 0 is less than or equal to 180. That's true. So that means you would shade downwards. So since we know we're in the first quadrant and we're shaded below that line, I'm at least in this big triangle here. So you don't have to shade it, but I'm at least there. But then we draw the second inequality. So the second inequality, if you plug in 0, 0 for that, you have 0 is less than or equal to 135. So that's also going towards 0, 0. So that means what we had before, so what I just drew, we've now chopped off the top part of that triangle. Do you guys see? It's now everything below the red line. So your final shaded area is a quadrilateral. There's 4 sides to it. It's right in there. Okay, that's your feasible region. So basically any point in that feasible region, like if I said 20, 10. So 20, 10 is right there in the feasible region. That would give you enough, you would have enough oats and enough flour available to make that number of bread. So 10 was y, so 10 whole grain and 20 honey oat batches. This makes sense, so any point in there will work. Okay, so let's see why this is useful. So it says in most linear programming problems, we're interested in how to maximize or minimize another function. Okay, so we use these all the time in real life problems. We're always talking about how to maximize profit or minimize cost or something like that. So in calculus, so if you use calculus to prove this, it says more advanced math shows that the maximum and minimum value occurs at a vertex of a feasible region. Okay, so going back to our example, when I say vertex, do you guys know what that means? The vertex of the quadrilateral formed. So it would be either at 0, 0, at 0, 45, whatever that point that is, or 36, 0. Okay, so one of those corner points. That's where a maximum or minimum of a function would occur. If it occurs at all. Okay, in order to find the maximum or minimum, we need to understand the difference between bounded and unbounded regions. So basically, bounded regions are completely enclosed. So this would be like a bounded region, so 4 sides. And then something like this would be unbounded. So see how that goes off forever to the right. So the vertex principle is what we're using. That's what I said. So if a maximum or minimum value occurs, it happens at one of the vertices. Okay, so number one, so suppose Brenna's Bakery in the previous example wants to maximize its profit from its bread sales. One batch of honey oat bread yields a profit of $40, and one batch of whole grain yields a profit of $30. Use the profit information and the data from the previous problem to find how many batches of each bread the bakery should bake. Okay, so my profit equation, so P. So P equals, remember X is the number of batches of honey oat. So for each batch of honey oat, I get a profit of $40. So it's 40X. For each batch of whole grain, you get a profit of $30, so 30Y. That's your profit equation. Now if I'm going to maximize or minimize this, so if I want to find the maximum of my profit, the only places where that's going to occur is at the corner points. So those are the only 4 points that we need to test. So some of these corner points are really easy. So go back to your graph, we're going to label them. So I'm going to call it A, B, C, and D. You might want to call them the same thing in that order for your notes. It's not confusing. Okay, some of these are really easy to find. We know that A was 0, 0. Let me write corner points so you guys remember what these are. So corner points. So A is 0, 0. B, that was pretty easy to find. Do you guys remember what that was?
45.
Yeah, 0, 45. It was right here. It was on our red line. It was the y-intercept on that line. So it's 0, 45. C, we don't know, so we're going to have to find that. And then D, if you look at it, remember that was on the blue line and that was the x-intercept, so it was 36, 0. Oops, I don't know why I just did that. Okay. I don't know what's going on. All right, so the last point that I need to find is C. Okay, now really think about how we do this. So this is kind of putting all this chapter together. How do you find what C is? Kern, what do you think? Yeah, you guys got it? Do you guys understand that?
I didn't know.
Okay, so he said you can use the addition or elimination method. We called it elimination. Do you guys remember that method? Allie, you with me? So we have 2 lines that are intersecting. So this first line we have and the second line we have. If we want to find where those lines intersect, didn't we do that in 3.1 or 3.2? If you want to find where 2 lines intersect, you can graph them and try to find it from the graph. Or you can use substitution and elimination. So we're going to use the elimination method. Okay, so in order to find, use elimination or substitution. So my 2 lines were my original constraints. 5x plus 2y equals 180. That was the line. So 5x plus 2y equals 180. And then 3x plus 3y equals 135. Okay, so we're going to use the elimination method. So let's multiply the top one by 3 and the bottom one by -3. Or -2, I mean. So that way my y's are going to cancel out. Do you guys see it? So I'm going to have 15x plus 6y equals 540. and I have negative 6x minus 6y equals negative 270. So when I add straight down, I get 9x equals 270. So x is 30. And then I plug back into any of them to find y. So I get 3 times 30 plus 3y equals 135. So that's 90, so I'm going to subtract 90 over. So I get 45. So I get 3y equals 45, so y is 15. So since those two lines intersected at C, that point C is 30, 15. Okay, let's go back and look. Does it look like 30, 15? Yeah, mine looks pretty close, and I didn't even have a grid. Looks pretty close. Okay, so these are long problems, so this is our last step, I promise. So we're trying to find what the maximum profit is. So I'm just going to plug these points into my profit equation. So my profit equation was the 40x plus 30y. So at 0, 0, what's my profit? 0, right? It was 40 times 0. You don't have to write this out if you see it. I'm just writing it for your notes. So you get 0. So just write p equals 0 if you understand. Okay, the next one I have p equals 40 times x is 0 plus 30 times 45. So I got 1350. Okay, next one. So if I do 40 times 30 plus 30 times 15, I get 1650. And the last one is just 40 times 36. Do you guys see where I'm getting these? 1440. Okay, so because of that vertex principle that I have above, one of these has to be the maximum. Well, which one's the maximum then? C, that's it. Okay, so your maximum was 1650, so 1650, or $1,650. Okay. Okay, I know these are long. You can do them. To motivate you guys to learn these, I don't know, some of you guys know that I taught at IU. So I taught at IU for 2 years. And while I was there, one of the classes, I didn't actually teach it, but it was one of the ones that a lot of my friends taught. It was a typical like freshman class that everybody took. It was called Finite. And in Finite, they did these for several weeks. So I tutored a lot on these. So you need to know these for college, for sure. Yeah, Kern. Did I what? You would write the maximum profit is $1,650. All right, so let's try this one. Okay, so this one's kind of putting it all together. So it says the annual profit in millions earned by a business is given by the equation P equals Y plus 2X, where X and Y are subject to the constraints given below. Find the maximum profit of the business. Okay, so the first step is you draw the constraints. Andrew, are you with me? So draw the constraints. So on these, it's helpful to find the x-intercepts and y-intercepts because sometimes those are your corner points. So when I plug in 0 for y, I get 3x equals 120, so x is 40. So 40 comma 0. When I plug in 0 for x, I get 120 for y. So graph it. So I'm guessing we can go by 10. So let me see, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Here's 120. So you can do tens. There's 40. Mine's not very straight. You guys can use a straight edge if you need to. Maybe I'll use the tissue box over here. Sometimes if you draw your lines really straight, you can kind of skip that substitution elimination step too. So, all right, the next one is really easy to see on the next one what the x-intercepts and y-intercepts are. 60, 0, 0, 60, right? Okay, think about the shading for both of those. So the first one, if you plug in 0, 0, you get 0 is less than or equal to 120. That's true. So you would shade the first one downwards. The next one, if you plug in 0, 0, you get 0 is less than or equal to 60. That's true. So shade downwards. And then your final two just tell you that you're in the first quadrant, because x is greater than 0 and y is also greater than or equal to 0. So it's saying x and y's are all positive, so first quadrant. So your final shaded region is this little quadrilateral shape. And on a lot of these, it will kind of look like this shape. So that's the first step. So draw the constraints. So draw this feasible region that we have. Okay, the second step is write the corner points. So do you want me to write these steps so you guys remember these? So corner points, and we'll label them. We'll call them A, B, C, and D. Doesn't matter what order you do, but for your notes, try to keep them the same as mine. Okay, A is easy to see, it's 0, 0. B is pretty easy to see too, that was the 60, right? So 0, 60. C, we don't know. Did anybody think they drew it really, really well and can guess? No? No guesses? All right, and then D is, what was it, 40? So 40, 0. Okay, so we need to find C. And it's not always C that you need to find in this case, since I drew them in the same order as before it is. Okay, so think about the two lines that are intersecting to get C. Do you guys have those lines in your head? You see them? The first one was 3x plus y equals 120. The second line was x plus y equals 60. I'm going to multiply the bottom equation by -1, so I'm going to make all the signs the opposite of what they were, so that when I add straight down, the y's will go away. So I get 2x, y's go away, equals 60, so x equals 30. Plug back in to find y, you had x plus y equals 60, so 30 plus y equals 60. So y equals 30 as well. So that means that point was 30, 30.
Wait, you mean 2? Why just 2?
No, it's not 30 times y, it's 30 plus y.
Sorry.
And then always look at your graph and see if it makes sense. Does yours look like 30, 30? Mine looks like 30, 30, yeah. If you were getting something like 90, 10, maybe you did something wrong, right? All right, now last step, plug into the profit equation. Your profit equation was given to you. It was P equals Y plus 2X. So my profit for the first one is Y was 0, X was 0, so 0. My profit for the next one was 60 was Y, X was 0, so you get 60. The next one I get 30 plus 2 times 30. So that's 30 plus 60, so 90. And the last one is y is 0 plus 2 times 40, so you get 80. Okay, what was the maximum profit? Yep. So max profit is, it says in millions, so it's 90 million. And then I usually say at what point, so at point 30, comma 30. And I wouldn't just say at point C or whatever, because you could have labeled those however you wanted to. So you probably didn't label them the same way as me. Okay? There, we'll stop for now.